Good day, ladies and gentlemen. In this lesson, we're going to mostly concern ourselves with the second part of Unit 2, Lesson 3, about linear functions and inequalities. But before we get there, let's do a quick review of the Unit 2, Lesson 3, Part 1. In linear functions, we're going to discuss two different types of the linear function, form number 1 and form number 2. Form number 1 is simply the slope-intercept form, and form number 2 is going to be a version of the point-slope form. In either case here, m is the average rate of change of the linear function, and the average rate of change of a linear function is constant. It can be hard to describe verbally. The verbal description of this average rate of change is as follows. If m is greater than 0, then on average, the function increases my units per each x unit. In like manner, if m is less than 0, then on average, the function decreases my units per each x unit. So let's look at some other topics from this before we go on. There we go. Now we can go here. We're going to come down here. Note a vertical line in the Cartesian coordinate system given by the equation x equals a is not a real function, and we've talked about that. It is an equation of a line. But if we look at this example number 1 here, and this example number 1 is given in form 2, where I have the point-slope form of that equation of the line. The domain is all reals and the range is all reals. We need to know that about linear functions. The domain, all reals, the range, all reals of a linear function. And I'm going to quickly go through this because I want this video to be concerned about linear functions and inequalities. We've talked about x and y intercepts. So if you need to pause the video at this point, please do and review how I'm going to find the y-intercepts. I'm going to let x equal 0, find the x-intercepts by letting y equal 0, and you can see the work that we have there. Moving forward, in light of the limited amount of time that we have, and let's talk about linear functions and inequalities. A linear function f of x is negative, or we say f of x is less than 0, for all x values where the graph of x is below the x-axis. You would not think that this would be an elusive topic, but for some students this is an elusive topic, and certainly a very important topic next year when we start talking about the graphs of the derivatives versus the graph of the original function. So we need to really completely understand when the graph of something or when a function is positive or negative. So this is important, and for some of us this will seem easy. That's okay. For some of us, again, as I stated, it may be a bit elusive. A linear function is positive, where we say f of x is greater than 0. That's for all x values where the graph of x is above the x-axis. So if I look at this example here, consider the graph of some linear function. This linear function, the x scale is in units of 1, the y scale is in units of 1, and I have this x-intercept here of 3, 0. That's 3, 0. And I have a y-intercept of 0, negative 2. And Part A asks us to name where the function is positive and explain why. Well, this is the graph of this linear function. We'll come up with an equation for that in a bit. But we say f of x is greater than 0 when x is greater than negative 3. So if x is greater than negative 3 over here, we say the function is positive. And why? Since the graph, here's the reason why. Since the graph of f of x is above the x-axis when x is greater than 3. This is the reason why we say that the function is greater than 0. And the second part asks us, hey, where the function is negative, and explain why. Well, this function is negative, or we say f of x is less than 0 when x is less than 3. Here's the reason why. Since the graph of f of x is below the x-axis when x is less than 3. It seems very straightforward, and you know what, ladies and gentlemen? It is straightforward. Please do not make this more difficult than it is. Okay? So again, I have find and give a verbal description of the average rate of change. This is part C. And we know, oh, if we look and if we use stickman, or we can calculate the slope analytically by using these 2 points. But if we look at stickman, we see that stickman would be walking up 2 and over 3. And therefore, the slope is 2/3. And therefore, we would talk about the verbal description of the average rate of change. We would say, on average, the function increases. It increases since the slope is positive, 2/3 y units per x unit. And what I'm going to do, again, in light of time, what we would want, part D says, hey, give the rule for this function using form number 1. And form number 1 is this slope-intercept form. Hey, and we know the slope, and we know the y-intercept is -2. So this portion right here, my goodness gracious, is going to be easy to find. Part E says, hey, find another point not given on the graph of the function, and name the function using form 2. We could choose any x value that we would want. I chose x equals 9, and I wonder why I chose x equals 9. Well, I chose x equals 9 because when I multiply 9 by 2/3, I get an integer, and the output is going to be very nice. So if I choose x equals 9, the function, and this actually should be, or this should be f of 9. Let's fill that in there, good. F of 9 is going to be 2/3 times 9 minus 2. 2/3 times 9, these 3's will cancel, will be 6 minus 2 is 4, and this is the point 9 comma 4. This is the point that I'm going to use. And keep in mind, there's infinitely many points that I can use to use form 2, which is the point slope form. I put the x in for the 9. I put the 4 in for the y. And I just write that I have the same slope. So this is the form 2. F of x is equal to 4 plus 2/3 quantity x minus 9. And we would hopefully that you would know by this point that these guys represent the same linear function. Let's go on to the last example for this short lesson. The last example says, and it talks about linear functions and inequalities continued. Any function f of x is greater than another function g of x, that is, f of x is greater than g of x. For all the x values, here's going to be the reason why that we're going to use, because the graph of x is above the graph of g. This is an extremely important topic next year, talking about one where the graph of one function is above the graph of another function. So do not take this lightly. This is extremely important, and it certainly will be assessed on the upcoming midterm. And again, we say any function f of x is less than or equal to another function g of x. That is, f of x is less than g of x for all the x values where the graph of x is below the graph of g of x. This is going to be our reason. So this first particular example about this might be a bit difficult to wrap your head around, but I don't think so. So I have the graph of this f of x 2/3 x minus 2. Obviously, well, hopefully it's obvious, that this is going to be the red, and let's underline that in red. This is going to be the graph of the red line here, because my average rate of change is positive, stickman is walking uphill. g of x here, this is going to be the blue line, and it's obvious on this graph since I have a negative average rate of change. I have a negative slope down 1 over 6. What I need to know, this has the red graph has a y-intercept here, easy enough to graph. The blue graph has a y-intercept here, easy enough to graph. Down 1 over 6 on the red, you're going to go up 2 over 3. This is actually the line that we graphed on the previous example. And what I want to know, the question asks, hey, where is f of x greater than g of x? Well, it's going to be greater than g of x. Let's postpone finding that point over here for all of these x values, because here the red line is above the blue line. F of x is above the graph of f of x is above the graph of g of x. What I need to do is I need to be very clever on finding, hey, how do I find this point? Because I need to find this x value. Well, I'm going to find that point. I'm going to go back to some Algebra 1 and Algebra 2 topics, and I'm going to solve this system of equations. I'm going to find out, hey, where the blue line and red line intersect, and I'm going to do that over here. And that's what's happening here. I'm setting the output of the blue line equal to the output of the red line, and I'm doing some arithmetic. I think I multiplied both sides by 6 and cleared the fractions. I got negative x plus 18, 4x minus 12, negative 5x is equal to negative 30, and that says that x is equal to 6. And that's where I got this 0.6 comma 2 in. I could put 6 into either equation, and that's going to give me the same y value. So this point right here is 6 comma 2. And I really only needed the 6, because if I wanted to talk about where f of x is greater than g of x, I'm going to talk about that in terms of x values. So here's the statement, and here's the answer to this question. F of x is greater than g of x when x is greater than 6. And here's the important part. Since the graph of f of x is above the graph of g of x when x is greater than 6. This is the part that you will certainly be assessed on, the reason why one graph is above or greater than another graph, or when one function is greater than another function. This example number 4 considers the graph of two linear functions that in this particular example tells you when they intersect. They're going to intersect at -4, -1. F of x has the positive rate of change, and g of x has a negative average rate of change. So what your task is going to be is to label the graphs appropriately with the f. You're going to label the graphs with the appropriate f and the appropriate g, and then you are going to answer this question when the graph of x is less than g of x. I would ask that you finish this particular example this evening. You will be given a copy of lesson 3 assignment, and we will discuss it tomorrow in class. Have a good day.